Suppose we're given the following rational function. H of x is equal to x over the square root of x squared plus 4, and we need to come up with a graph for it. Well, we could try to come up with some of the attributes. Let's say, for example, that we wanted to come up with the vertical asymptote. So we'd look at the denominator and we would ask ourselves, is it possible for this denominator to equal 0? Well, that's like saying, is the square root of x squared plus 4 equal to 0? Which is only true if x squared plus 4 is equal to 0. Is that possible? No. So anything that we square is going to be positive, and if we add something to that, it will just be a larger positive number. It will never equal 0. So for our vertical asymptote, since the denominator will never equal 0, we're going to say that there's none. What about our horizontal asymptote? Well, there are a few ways that we could do this. We could look at the degree of the leading term. The problem here is that we have this big square root in the denominator. So let's reason on what exactly the horizontal asymptote is. Remember we said that a horizontal asymptote represents behavior as the function goes out to infinity. So as we go out to infinity, if we get, for example, substitute our value of x here as 1,000,000, square that, and then add 4, is this plus 4 really going to make that much of a difference if we're squaring 1,000,000? No. That number is basically about 1,000,000. So what that means is that if we're looking at the horizontal asymptote, we're really looking at what happens with x over the square root of x squared. Keep in mind that when we take a square root, there are two possibilities. Either we have a positive answer, so we could have x over the square root of x squared is just x, or we could have x over the square root of x squared being negative x. For example, I know sometimes we can get lost in the numbers. If I say square root of 36, what is that? Well, it's going to be 6 because 6 times 6 is 36. But it's also equal to negative 6 because a negative 6 times a negative 6 is equal to a positive 36. So we can either have a positive version of our answer or a negative version of our answer. So if we consider the positive version, x over x is 1. And if we consider the negative version, x over negative x is negative 1. So we have really two horizontal asymptotes here, one at positive 1 and the other one at negative 1. So before we forget, let's just sketch that in here. We're going to have an asymptote at positive 1, horizontal asymptote through 1, and another horizontal asymptote through negative 1. So no vertical asymptote. So that means that there are no discontinuities. There's no place where the graph is going to break. Let's think about our intercepts. What would our x-intercept be? Our x-intercept is anything that makes the numerator equal 0. So basically anything that makes x equal to 0. So when x is 0, we have an x-intercept. So there's our x-intercept. We know that for our function values, if I put in a positive number here, regardless, this is always going to be positive because I'm squaring it. So basically, if I put in a positive number here, I'm going to end up with a positive number divided by a positive number, which is positive. So on the right-hand side of the graph, we're only going to have positive values, so we're going to get closer to that top asymptote. But on the other side, if I put a negative number in for x, this number down here will always be positive regardless, because again, if I square a positive number or a negative number, it's always going to be positive. So again, if I put a negative number here, Down here will always be positive. When I divide it regardless, I'm going to end up with a negative number. So on the left side of the graph, I'm just going to basically only end up with negative numbers. So I'm going to approach the bottom asymptote. So this is roughly what the graph looks like.